Very good morning to all of you. Welcome to my YouTube channel. So students, today we will study the successive differentiation with some examples. So what is the successive differentiation? So basically it is the process of a repeated differentiation, or we can say it is the process of differentiating a given function successively times, and the results of such differentiation are called the successive derivatives. So if y is a function of x, what I have to do here, I have to basically differentiate this y with respect to x. By doing this, I will get the first differential coefficient, which is given by dy by dx, and we can say this is the first differential coefficient of y with respect to x. So name it as equation number first. So if I have to find the second differential coefficient, what I will do, I will differentiate this equation first with respect to x again, because this is again a function of x. So this can be differentiated. So hence, for finding the second differential coefficient, that is d2y by dx square, I have to differentiate equation first with respect to x again. Similarly, for third differential coefficient, I have to differentiate equation second. So name it as equation second with respect to x, so that I will get the third differential coefficient. So by proceeding in this manner, we can find the nth differential coefficient, that is dny by dx raised power n. So repeating the differentiation is known as the successive differentiation. So this means if y is a function of x, I will write here y is a function of x. So if I have to differentiate this y with respect to x, what I will get? I will get dy by dx, and this is the first differential coefficient. So this is the first differential coefficient of y with respect to x. So this means what I am doing here, I am differentiating this with respect to x. I will say that I am differentiating this equation with respect to x. So name it as equation number 1. So if I have to find the second differential coefficient, I will differentiate the equation number 1 with respect to x. So I will write here again, differentiating equation first, differentiating equation first with respect to x. What we will get? We get d2y by dx square, or we can write it as d by dx of equation 1. What was equation 1? It was dy by dx. So I will get d2y by dx square. So this is the second differential coefficient, second differential coefficient of y with respect to x. So similarly, name it as equation number 3. It is equation number 2. So similarly, again differentiating equation second with respect to x, we get what we will get? We get the third differential coefficient. So I will write here d3y by dx3. This is equal to d by dx of equation second. What was equation second? It was d2y by dx square. So this is the third differential coefficient, third differential coefficient of y with respect to x. So proceeding in the similar manner, if I will differentiate this equation, or I will repeat this process up to n times, what I will get? I will get the nth differential coefficient, so which is given by dny by dx raised power n, which is equal to d by dx of, this will be dn minus 1y divided by dx raised power n minus 1. Okay, so this is the nth differential coefficient of y with respect to x. So this is the process of successive differentiation. So basically we have to differentiate the function successively times. Now we will solve some questions on this topic. So further, before solving some questions, I will tell you about the notations of successive differentiation. So the other notations for successive differential coefficients of y are, so dy by dx, this is the first differential coefficient. So this is denoted by y1. It is also denoted by y1, or we can say y dash, or by dy, or by f dash x. Similarly, for second differential coefficient, that is d2y by dx square, this is denoted by y2, or I can write it as y double dash, or d2y, or f double dash x. Similarly, d3y by dx cube, this is equal to, this is denoted by y3, or y triple dash, or d3y, or we can write as f triple dash x. Similarly, for the nth derivative of y with respect to x, this is equal to yn, or y, this goes to y nth derivative, and this is nth derivative of y with respect to x, and f nth derivative of y with respect to x. So these are the notations for the successive differential coefficients. So note that the symbol dn divided by dx raised power n before a function of x indicates that the function is to be differentiated n times in succession. So this symbol indicates that the function is to be differentiated n times in succession. So this is the process of successive differentiation. Now we will solve some questions. So first example is that find the fourth derivative of the function given is log square root of 3x plus 4. So what we have given, that we will write here, let y is equal to the log then square root of 3x plus 4. Okay, so I will write this function again. I will write it as log 3x plus 4 whole raising power 1 by 2. So this is basically the log m raising power n formula, so which is equal to n log m. So I will apply this property here. So I will get y is equal to 1 by 2 then log of 3x plus 4. Now what I have to do, I have to differentiate this. So I will name it as equation 1. So differentiating equation first, with respect to x, we get what we will get. We get dy by dx. So this is equal to basically the d by dx of y. What is y? Y is 1 by 2 log of 3x plus 4. So now the differentiation of this is given by, so 1 by 2, then log differentiation of log 3x plus 4 is equal to, so I will write here like this term so that it will be more clear to you. So this means we have to differentiate only this part, that is 3x plus 4. So because 1 by 2 is constant, so I will get the answer, it is log, write it as log of differentiation of log of 3x plus 4. Okay, so now differentiation of log 3x plus 4, it goes to 1 by 3x plus 4, then differentiation of 3x, differentiation of 3x is 3. So now final answer will be 3 by 2 into 3x plus 4 whole raised by minus 1. So this is our first differential coefficient, or we can say first derivative. Similarly, I have to again differentiate this equation, name it as equation number 2 with respect to x. So differentiating, or I will write again, differentiating equation 2 with respect to x, we get, what we will get? We get the second differential coefficient, that is d2y by dx square. So this is equal to d by dx of dy by dx. And what was dy by dx? So it was d by dx of 3 by 2 into 3x plus 4 whole raised by minus 1. So now I have to differentiate this term. So it is d2y by dx square, which was equal to d by dx of dy by dx, and it was d by dx of 3 by 2 into 3x plus 4 whole raised by minus 1. So now I will solve this. So it will become 3 by 2, then power goes down, minus 1 into 3x plus 4 raising power minus 2, then differentiation of 3x, it is 3. So solving this, I will get minus 9 by 2 into 3x plus 4 whole raised by minus 2. So this is d2y by dx square. So name it as equation number 3. So again, differentiating equation 3 with respect to x, we get, what we will get? We get d3y by dx cube, and this is equal to d by dx of d2y by dx square, and this is equal to d by dx of, that is the derivative of this function, okay, that is minus 9 by 2 into 3x plus 4 raising power minus 2. So now it becomes minus 9 by 2 into differentiation of this part, so power goes down, so it will become 3x plus 4 raising power minus 3 into 3. So solving this, we get 27 into 3x plus 4 whole raised by minus 3. So this is our third differential coefficient. So now I will find the fourth one, because we have to differentiate this function up to 4 times. So again differentiating. So differentiating equation 4 with respect to x, we get, what we will get? We get d4y by dx4, and this is equal to d by dx of 27 into 3x plus 4 whole raised by minus 3. So which is equal to 27 into minus 3 into 3x plus 4 whole raised by minus 4, then into 3, that is the differentiation of 3x. So which goes to minus 243 into 3x plus 4 raised power minus 4, or we can write it as minus 243 divided by 3x plus 4 whole raised power 4, which is the answer. So this is the fourth derivative of the function log square root of 3x plus 4, hence solved. Next example is that if y is equal to e raised power x sin x, prove that d2y by dx square, this is equal to 2 e raised power x cos x. So for this, what we will do first of all, we will write what is given, that is y is equal to e raised power x into sin x. So now what I have to do, I have to find the second derivative of this function. So name it as equation 1. So differentiating equation first with respect to x. Equation first with respect to x, we get, what we will get? We get dy by dx. So this is equal to, here I will apply the formula u into v formula, which is equal to u into differentiation of v, then plus v into differentiation of u. Okay. So this means d by dx of y was e raised power x into sin x. So it goes to first into differentiation of second, that is sin x, then sin x means second into differentiation of first, that is d by dx of e raised power x. So now it becomes e raised power x, then differentiation of sin x is cos x, then plus sin x, and differentiation of e raised power x is again e raised power x. Taking e raised power x as common, so we get cos of x plus sin of x. So this is our first differential coefficient, or we can say dy by dx, or we can also denote it by y1, or we can denote it as f dash x. Also we can denote it by dy. So this is the first differential coefficient. So name it as equation number second. So again, differentiating equation second with respect to x, we get, what we will get? We get d2y by dx square, so which is equal to d by dx of which term? E raised power x into cos of x plus sin of x. Okay. So I will write here d2y by dx square, so which is equal to d by dx of e raised power x, then it was cos of x plus sin of x. So again here I will use the u into v property. So here it becomes first into differentiation of second, that is cos of x plus sin x, then second into differentiation of first. So it will become e raised power x, it goes to differentiation of cos x is minus sin x, and sin x goes to cos x, then it is cos of x, then plus sin of x, and differentiation of e raised power x is again e raised power x. Taking e raised power x common, we get minus sin x plus cos x, then plus sin x plus cos x and plus sin x. From here, minus sin x and plus sin x get cancelled. E raised power x is equal to then 2 times cos of x. So what we will get? We get that d2y by dx square, this is equal to e raised power x into 2 times cos of x, which is the answer. Example is that if y is equal to cos inverse of x, we have to show that y2 into 1 minus x square minus x into y1, this is equal to 0. So note that here y1 is basically the first differential coefficient, or we can say it is the first derivative, and y2 is the second derivative, that is d2y by dx square. So now what is given here? Y is given and it is cos inverse of x. So name it as equation number 1. So differentiating this equation with respect to x, we get what we will get? We get dy by dx, and this is equal to differentiation of cos inverse of x goes to minus 1 divided by square root of 1 minus x square. Now cross multiplying by square root of 1 minus x square, we get 1 minus x square, square root of 1 minus x square into dy by dx, and this is equal to minus 1. So name it as equation number 2. So again, differentiating equation 2 with respect to x, we get what we will get? We get here we have to use u into v formula. So this is u and this part is v. So it will become first into derivative of second. So derivative of dy by dx goes to d2y by dx square. Then plus second into derivative of first. And derivative of first goes to 1 by 2. Then it goes to square 1 by 2 into 1 minus x square raising power minus 1 by 2, and derivative of minus x square goes to minus 2x. So and differentiation of minus 1 goes to 0. So now it will become 1 square root of 1 minus x square into d2y by dx square, then plus 2 and 2 gets cancelled. So it will become dy by dx into minus x divided by square root of 1 minus x square, and this is equal to 0. Now we will cross multiply this by square root of 1 minus x square. So by cross multiplying to this side and also to this term, this side goes to 0, and this will become 1 minus x square square root of, I will write like this, square root of 1 minus x square, then whole square into d2y by dx square, then minus x into dy by dx, this is equal to 0. So now this 2 and square root get cancelled. So it will become 1 minus x square into d2y by dx square, minus x into dy by dx, this is equal to 0. So now we know that the d2y by dx square is basically denoted by y2. So I will write here 1 minus x square into y2, and similarly dy by dx is also denoted by y1. So I will write here y1. So this is the answer. So this is the this was what we have to prove in this question. Thank you.